Hi people, and welcome to this video. In this video, we'll be working on the Mathematics Paper 1 for June 2024, and this is specifically from the Gauteng province. Remember that this paper is worth 150 marks and the time allocated is 3 hours. Okay, our instructions, just remember to round off to 2 decimal places unless stated otherwise. The diagrams are not necessarily drawn to scale, and there is an information sheet with your formulas at the end of the question paper. Okay, with that being said, let's get into this video. Question 1.1.1 says we have to solve for x given this equation. So notice the form it is in. We have a value multiplied by another value and it gives us 0. The only way this is possible is if the first value, the first factor we have here, 2x, is equal to 0, or the second is equal to 0. And then this will work out. So here to solve for x, we'll divide both hand sides by 2. Therefore, x is equal to 0. Or we can transpose that 4, so it becomes negative 4. And then divide both hand sides by 3. Therefore, x equals negative 4 over 3. And that is our answer. Moving on to the next question. Question 1.1.2 says we need to solve for x correct to 2 decimal places. So it means we're going to have irrational solutions and we're going to have to use the quadratic formula here. So in our equation, you see that it's not in its standard form. We need to transpose negative 1. So we have 2x squared minus 4x, and now this is plus 1 is equal to 0. Okay, now we're not going to factorize, we're just going to use the quadratic formula, which looks like this. And then, because this is in its standard form in the form of ax squared plus bx plus c, we can just substitute these. So x is equal to negative, and we have negative 4 plus minus the square root of negative 4 all squared minus 4 times a, which is 2, times c, which is 1, all over 2a, which is 2. And let's substitute our values. So x is finally equal to, and we have, okay, in decimal form, this is 1.71, or x is equal to, and we're going to change that to the minus, and it is 0. You see that's going to round down, so that is 2.9. And that is our answer. Moving on to the next question. Question 1.1.3, we are given this inequality and we need to solve for x. So it's a quadratic inequality because the exponent of 2 is here. When you distribute, you're going to get x squared, and 2 will be the highest exponent on x. Now, with this inequality and the way they have put it, it's actually the turning point form of a quadratic function. But because it's for 4 marks and we need to get marks for doing certain things, I'm just going to go ahead and distribute here. But there would actually have been a very easy way to find your critical values and then solve. But we're going to have to take certain steps still. Okay, so here's what we have. We're going to go ahead and square this. So this is x squared, and then we have positive, and then we square the second term, and that gives us positive 4. Then first term multiplied by second term is negative 2x, and then you just multiply this by 2 to get negative 4x. Now at this point, you see you still have 1 here. You might as well just bring it over. So it becomes minus 1 is greater than or equal to 0. And now we have x squared minus 4x and plus 3 is greater than or equal to 0. Open up 2 brackets, find your factors, okay, greater than or equal to 0. X times x gives us x squared. And then factors of positive 3 that can give us a negative 4 in the middle, meaning both values must be negative. So 3 is a prime number, so it's simply just negative 3 and minus 1. So this means that our critical values, if you had to solve for x here, x is equal to 3 or x is equal to 1. And now we can draw our graph. So with our graph, it is a concave up parabola because as you can see, the value of a in x squared is positive. And our critical values are 3 and 1. So 1 is over here, 3 is over here. All the inequality is asking for is the values of x for which this expression will be greater than or equal to 0. When it's referring to this, okay, this is a result of substituting x values. So you're going to substitute x values and you will get y values. And they want you to tell them the values of x for which those y values will be greater than 0. We know that on a parabola or on any graph, the y values are greater than 0 over here, okay, on the positive part of the y-axis, and then negative over here on the negative part of the y-axis. So if you want positive values, values greater than, of course, or equal to 0, you need to look above the x-axis. The x-axis will be your marker. Below the x-axis gives you negative y values. Above the x-axis, positive y values. So let's highlight all the parts of the graph that lie above the x-axis. And if you line them down to the x-axis, do you see now that these values, look at where they point towards. They are values that are pointed towards the left-hand side of 1. So this means that x is less than 1, or, and if we look on the other side, line this down to the x-axis to understand these x values, it's pointing towards the right-hand side of 3. So these are values that are greater than 3. So we can say x is less than 1 or x is greater than 3. And that is our answer. Moving on to the next question. Question 1.2 says, given the equation, the square root of x minus 2 is equal to 4 minus x, then 1.2.1 says, without solving for x, show that the solution lies in the interval where x is greater than or equal to 2, but less than or equal to 4. So we're not solving for x, but we need to show that the solution that we're going to get, if we did solve for x, it would lie within this interval, okay, between 2 all the way to 4. Okay, let's look at this equation. X minus 2 is equal to 4 minus x. And how can we actually show them that they're going to be solution, or the solution lies within this interval? Well, okay, it's a solution, meaning you are able to solve for x. You are able to find a real value for x. So for this to even have a solution, we can analyze each side of this equation. And you see, with the square root, the square root is really limited because there's certain things you can't put under the radical because those will cause your solutions to be non-real. And here's the thing. So for us to have any solution or any possibility of a solution, then let's look at this radical, right? It's x minus 2. If you have a negative value, okay, a number less than 0 under the square root, it's going to become non-real. So for there to even exist a solution, this part needs to be greater than or equal to 0. Not this whole part, specifically what's under the radical. It shouldn't be negative, meaning we need it to either be x minus 2 can be greater than or equal to 0. Okay, it can be equal to 0. I'm not saying that at 0 we will have a solution, but the expression will produce real values. Okay, and where there are real values, we'll be able to find a solution within that. So this is what we have, and it's linear. So here we could just say that x needs to be greater than or equal to 2. Okay, so we've analyzed the one side of it. For there to even be any solutions, then x needs to be greater than or equal to 2. Now this side, 4 minus x. Okay, with this one, it's highly dependent on this. Since we're saying that square root of x minus 2 is equal to 4 minus x. But you see that if what is under the radical must be positive, when you square root this, it's also going to be positive. Meaning, for this to be real as well, this part, 4 minus x, must be a value that is positive or equal to 0 as well. Not really for the same reason, but because if this was negative and we're saying that these are equal, then you're actually saying that what you got here was a negative value, but we know we can't get a negative value here. Okay, so 4 minus x must be greater than or equal to 0, meaning 4 needs to be greater than or equal to x. And let's just rewrite that with x first. We're just saying that x needs to be, and then you put 4 here, then you see that the inequality is just facing the 4. So draw it facing the 4, and there's the equal to. So we're just saying that x needs to be less than or equal to 4. Okay, so it needs to meet these two criteria for it to even have a solution. Okay, I'm going to put this on a number line so I can understand where these values are, but I can see where they're pointing. So if this is 2 and this is 4, and we're saying that x needs to be greater than or equal to 2, okay, so it can be equal to 2, it can be values greater than 2. And then here, it can be equal to 4, and it can be values less than 4. So do you see now that this concludes that the solution, okay, will only lie where this has any real solutions. And that's specifically where x is greater than or equal to 2, but less than or equal to 4. These would produce real solutions. And so within those real solutions, within those real values of x, we will be able to find the actual solution there, the actual answer that makes the left-hand side of the equation equal to the right-hand side. Okay, so there we were able to prove that using this logic. So yeah, this one has to do with a little bit of logical reasoning to just think about how these can stay real. Okay, so that is our answer with that. We would need to show them the inequalities that we were able to find, and then, that it's finally equal to this. So these two inequalities simplify to this, okay, because they're just written separately here, but they can actually be written as one based on their relationship. Okay, moving on to the next question. Question 1.2.2 says, solve the equation. Okay, so now we can go ahead and solve this equation and find out what exactly is our x value. Okay, so here's our equation, and we can go ahead and square both hand sides because the side is already isolated here. So square this side and square that side, and now that radical breaks open and we have x minus 2 is equal to, square the first term, that is 16, square the last term, that is positive x squared. First term times second term is negative 4x times 2 is negative 8x. Okay, so our x squared is already positive on this side, so we can rewrite this as x squared minus 8x, and then you're going to transpose, which is minus x, and so that just gives you minus 9x, and then we have positive 16, and when you transpose it's plus 2, so that's positive 18, okay, is equal to 0. Okay, and we have to factorize this, so open up two brackets, equate to 0, and we're saying x times x give us x squared, and factors of positive 18 that can give us negative 9. Because only the middle is negative, these will both be negative. So factors of 18 that can give you 9, 6, and 3. And so x is equal to positive 6, or x is equal to positive 3. Now you can't just take both solutions. You see, we deliberately squared both hand sides. That can tamper with the solutions. So let's check if these solutions are valid. So we will use the equation, right? The equation of the third. And in place of x, we're going to try substituting these x values. So let's try 6 to check if 6 is a valid solution. So 6 here and 6 here. 6 minus 2 is 4. Square root of 4 is 2. 4 minus 6 is negative 2. So do you see that these are not the same number? The equation is not balanced. The left is not equal to the right. Therefore, x is not equal to 6. Let's try 3. So if we put 3 here and 3 here, 3 minus 2 is 1, and square root of 1 is 1. 4 minus 3 is 1. Our left-hand side is equal to our right-hand side. So therefore, x is equal to 3, but it's not equal to 6. And that is our answer. Moving on to the next question. Question 1.3 says solve for x and y simultaneously, and they've given us two equations. As you can see, one is linear. There's no x squared, there's no xy, anything like that. So we can just go straight for the linear and make y the subject. So if you leave y on the left-hand side and transpose the 3, you have this is equal to, the 2 is still on the right, transpose that 3x, it's negative 3x, and we can call this equation 1. So you can go ahead and call this one equation 2. So we're going to substitute equation 1 into equation 2. And this is, so anywhere you see y, just replace it with 2 minus 3x. So there's y squared. So we'll say 2 minus 3x all squared is equal to 2x squared minus 1. Okay, so square the first term, it's 4. Square the last term, it is positive 9x squared. First term times second term is negative 6x times 2 is negative 12x. And this is equal to, we have, let's just transpose it because this is already positive here. So minus 2x squared, and that becomes plus 1 is equal to 0. 9x squared minus 2x squared is 7x squared. And then we have negative 12x. Then 4 plus 1 is 5. So plus 5 is equal to 0. Okay, so we have to factorize. And I'm going to use the cross method here. So we need factors of 7x squared. What times what gives you 7x squared? That's 7x times x. And factors of 5. Now I can already see only the middle is negative, meaning both of these will be negative. So you need to think about how you're going to structure the factors of 5, which of course are just 5 and 1, in a way that you end up with negative 12. If you put the 5 here, it's not going to work. You're going to say 7 times 5, which is 35. But you're going to have to put the 5 here instead. So now if you say 7x times negative 1, we get negative 7x. And then x times negative 5 is negative 5x. And that indeed gives us negative 12x. Okay, our middle term. So our factors are 7x minus 5 times x minus 1 is equal to 0. And to solve for x, we're going to say 7x minus 5 equals 0. But if you transpose that, it is positive 5. And then x is equal to, divide both hand sides of the equation by 7. So it's 5 over 7. Or here, x is simply equal to 1. And there we go with solve for x. So we have x. Look for the equation that helps to solve for y easily. And that will be equation 1 because y is the subject. So y equals 2 minus 3x. Y equals 2 minus 3x. So 5 over 7. Or y equals 2 minus 3 times 1. And then we just have to solve here. So y equals, when we multiply, that is 15 over 7. You could put this over 7 by saying times 7, which is 14 over 7. And then 14 minus 15 is negative 1. So this is negative 1 over 7. Or y equals 2 minus 3, which is negative 1. And so these are our solutions. When x is equal to 5 over 7, y equals negative 1 over 7. Or x is equal to 1 and y equals negative 1. Moving on to the next question. We are on the last question for question 1. And it says, if r plus 2s is equal to a, okay, and r minus 2s is equal to b, prove that rs is equal to a squared minus b squared over 8. Okay, so looking at this, I thought, okay, maybe we could just try to make, r the subject here and s the subject here. But you see how they both equations, right? Both equations include r and s. And then this one includes a, and then that one includes b. So let's try to look for another way out of this. And the way out that I'm seeing here is, yes, this has a and this has b, but we could take advantage of that. This has a squared and this has b squared. So why don't we just square this equation? So we will have a squared, square that, and we'll have b squared. And then we can just ensure that it ends up saying a squared minus b squared by saying this equation, once it's squared, minus this equation, once it's also squared. Okay, so let's try that. So we have r plus 2s is equal to a, and we have, okay, let's just go ahead and square it at this point. So if we square this, we get, so a squared, and I'll just say a squared is equal to, and we can distribute that. That is going to be r squared, and then you're going to say 2s all squared, which gives you a positive 4s squared. And then r times 2s, which is 2rs, and then times 2, which is positive 4rs. Okay, so this is what we have here. And I'll go ahead and call this equation 1. And then we're going to take the other equation we have, which is r minus 2s is equal to b, and we can just square both hand sides. So square this, and now we can say, therefore, this means that b squared, okay, is equal to, and this is r all squared, and then square that, that's positive 4s squared, and then first term times second term is negative 2rs, then times 2, because it becomes double, okay, so it becomes negative 4rs. And now I'm going to call that equation 2. And I'm simply going to say, because I can see it says a squared minus b squared, I'll say equation 1 minus equation 2. And let's go. So left-hand side minus left-hand side, so that's a squared minus b squared is equal to, and then right minus right. So that is r squared plus 4rs plus 4s squared. Now, when we subtract here, instead of using brackets, I'm just going to directly subtract by each term. So that is, the first term is r squared on the right hand side. So that is minus r squared. And then if we say minus negative 4sr, you're saying minus negative. Okay, so it becomes a plus 4rs. Okay, and then we have here minus 4s squared. And let's see how they simplify. So this is still a squared minus b squared is equal to, and then these cancel. And okay, so look at the things that cancel. Those two will cancel, and these last terms will also cancel. So you're only left with these two, which are like terms, and they become 8sr. Okay, rs. I'll leave it as rs because I just want to make sure that it is the same. And now you see that in order to get rs as the subject, we simply divide both hand sides of this equation by 8, and now rs is equal to a squared minus b squared over 8, and that is our answer. Okay, so that is how we solve for that question, and that is it for question 1. Question 2 says, given the arithmetic sequence, we have 85, 82, 79. Okay, it's arithmetic, so it's linear. And we can already see that we are simply just subtracting by 3 every time. Okay, minus 3 is 82, minus 3 is 79, and so on. They want us to determine a simplified expression for Tn, so for the general term. So just find the general term and simplify it. Okay, so Tn in an arithmetic sequence is equal to a plus n minus 1 multiplied by d. And so the value of a is 85, as we can see. Tn equals 85 plus n minus 1. And the difference is negative 3, okay? Because if you said 82 minus 85, that's negative 3. 79 minus 82 is negative 3. Okay, so that's negative 3. And we just have to write this in its simplified form. Okay, so distribute this negative 3. So we're saying Tn is equal to 85, and then that multiplies to the negative 1 to give a positive 3, and then minus 3n. So Tn is equal to, we can say negative 3n plus 88, okay, or 88 minus 3n is also fine. And that is our answer. Moving on to the next question. Question 2.1.2 says, which term would be the first negative number in the sequence? So which term, okay, would be the first negative number? We can just find out, since it's negative, we can find out where our terms will have negative values. So where Tn will be less than 0, negative. Okay, so that is negative 3n plus 88 is less than 0. Now, it would be best to just leave this here because you're going to still have to divide or still figure out that inequality. So negative 3n is less than, and transpose that is negative 88. And then we'll divide both hand sides of this inequality by negative 3. Now remember, when you multiply or divide by a negative value, it's going to cause that inequality to change signs. And so this is now n is greater than, and what is negative, or just say 88 divided by 3. Okay, and that gives us, we can just leave it as 29.3 recurring. Okay, 29.3 recurring. And so what this means is we're only going to take term values, eh? We can't take these type of decimal numbers. So if it's saying that this will happen where our n value is greater than this number 29.3 recurring, think about values greater than this. Okay, greater than, just follow the arrow, the way the inequality looks. It's shooting towards this side. Okay, so what is the immediate number greater than this decimal? It's 29.3 recurring. So the next number greater than this would be at 30. So now we would know it is at term 30. That's where we'll have our first negative value. So we can say term 30 or T30 will be our first negative number in the sequence. Okay, and that is our answer. Moving on to the next question. Question 2.2 says a quadratic sequence with general term Tn has the following properties. Okay, so it has nothing to do with that one. So this is a quadratic sequence, a new sequence with the general term Tn has the following properties. Term 11 is equal to 190. So they've given us one complete term here. But then they say Tn minus Tn minus 1 is equal to 4n minus 3, where n is greater than or equal to 2. And they want us to determine the first term of the quadratic sequence. Okay, interesting story. Let's try to unpack this. So the whole point is, okay, I'm just going to put down the order of the way this goes. We have a quadratic sequence, right? And then below it, you have the first differences. And then you have the second constant difference. So they specifically said Tn, which stands for the general term of the quadratic sequence, minus Tn minus 1. So here's the thing about that. If we have Tn, it also stands for the last term, okay? Meaning the last term when our last term is unknown. We're just saying that the way we can generally find it is to find Tn. And we're specifically looking at that because they say Tn minus 1. Okay, so if this is the last term, what is Tn minus 1? It's a term less than what this one was. So it's a term before this, meaning this is the second last term. So what they're saying in the quadratic pattern is we have this situation, okay, where we have the last term minus the second last term, and then it gives us 4n minus 3, where n is greater than or equal to 2. What does that mean? Well, where do you ever take the last term? Why do you ever take a term after this and then subtract it by the previous term? Okay, so even if we weren't looking at it as the last term, but just as the general term, why would we ever take this term and subtract it by the previous term in a quadratic pattern? We do that only to find the first difference. So it means that this is the formula for your first differences. And then that already gives us a lot of information. If this is the formula for the first differences, specifically for values that are greater or equal to 2, so it starts at 2 and then 3, 4, 5, and numbers greater than 2. Okay, so that would mean that we can actually find the first terms in the first differences. So to find the first term here, we would say 4 times 2, so starting at 2, and then minus 3. And then to find the second term in the first difference, you say 4 times 3 and then minus 3. So now that we have this, right, remember that this is in the form of dn plus c, meaning 4 is your difference, okay, difference n plus a constant. And so that means we know the second constant difference, though we could have also found it like that. But we wouldn't even need this term, you see. We have the second constant difference, it's 4. And this is already complete in our pattern. So we've got 2 terms here. We only needed 1 really. We don't really need that, clearly, because we have the second constant difference from this formula. Okay, let's just simplify this one. This is 8 minus 3, which is 5. So we know the first term in the first difference is 5. The second constant difference is 4. And we don't know what the first term in the quadratic pattern is. But we can probably find it now because they gave us this information. T11 equals 190. Okay, so using what we have here, let's go ahead and find the value of A and B. We can actually do that. So you see in your quadratic pattern, we take the first terms of all these patterns, the quadratic, the first differences, and the second constant difference, and we equate them to the following. We say 2a is equal to 4, and then 3a plus b is equal to, we're saying 5 in this case. And then, of course, this is a plus b plus c, but we can't really do anything here because we don't know what that first term is. We're trying to find it. So let's just find a and b first. So if 2a is equal to 4, then it means that a is equal to 2. And then we need to find b. So 3a plus b, that's 2 plus b equals 5. And so b is equal to, that's going to become 6. If you transpose it, it's 5 minus 6, which is negative 1. Great, we have a and b. We may not have c, but we have this information. So let's complete our quadratic terms and term. Okay, so Tn is equal to, this is going to be in the form of an squared plus bn plus c, because it's a quadratic pattern. So its Tn formula is Tn equals 2n squared minus n plus c. Do you see that c is the only missing thing here? So we can find c so that we can find the first term. We'll find c by substituting this. Term 11 is equal to 190. So term 11 equals 190. And we're saying term 11. So in place of n, substitute 11. So it's 2 times 11 squared minus 11 plus c. And then we'll say term 11 is equal to 190. So in place of term 11, say 190. 11 squared is 121 times 2 is 242. So 242 minus 11 is 231. Okay, so we have 231 here plus c. And then if you transpose it, that is 190 minus 231. Might as well just say 231 minus 190. That is 1. That's going to be 13 minus 9 is 4. So that's negative 41 we'll get. So c equals negative 41. And now that we have c, we can find that first term. Yeah, it's a long, but that's why it's 5 marks clearly. So we'll just say Tn equals 2n squared minus n minus 41. And now we can finally find the first term. So we'll say term 1 is equal to 2, and in place of n, we substitute 1 all squared minus 1 and then minus 41. So term 1 is finally equal to, that's going to be 1 times 2 is 2, minus 1 is 1, minus 41. 1 minus 41 is negative 40. And that is our answer. Okay, so that is it for question 2.2. Moving on to the next question. Question 2.3 says, the sum of the first 50 terms of an arithmetic sequence is 1275. Calculate the sum of term 25 and 26. So what they're asking us to do is find what term 25 plus term 26 is equal to. Okay, so this is the whole goal. Given this information, so the sum of 50 terms, meaning S of 50 equals 1275. And then there's not much information they give us here. So what can we do with this, and how can we get this to look like this? Well, the sum formula, we have two formulas, of course. We have the Sn equals n over 2, and then 2a plus n minus 1 times d. And we can use this one as well, n over 2, a plus l, okay? Because they're arithmetic. Now, okay, let's say we just use the simple one. I don't think it would matter though, but I'm just trying to keep things simple. If we use this one, what does this give us? We just know that the sum of 50 terms is 50 over 2 and then a plus l. And I don't know what a plus l is. Okay, so in this case, a would be your first term, l would be your last term. If we're saying the sum of 50 terms, we're saying term 50 is the last term. Okay, how about, you see, there's a way we can find this, but it's going to look like a simultaneous equation, and it's going to be in terms of a and d. Here's the thing. Okay, so you will notice that there is this section, right? It's usually in textbooks. So it tells you how to find the general form of this formula, right? To derive it, and also to derive it as 2a plus n minus 1 times d. From that, you learn how to rewrite terms in terms of A and D. Here's what I mean. So it's an arithmetic pattern. You know that the first term is always A. But as you keep going, what we keep doing is we add a constant difference. So term 2 is going to be A plus D. And then term 3 is going to be A plus 2D. And then term 4 is going to be A plus 3D. Do you notice a pattern with this? You see, the term number and the coefficient of D, they have a relationship going on there. So the term number is always going to be one more than the coefficient of D. Or you can see it as the coefficient of D is always going to be one less than the term number. See, same thing here. We have 2D for term 3 and then 3D for term 4. So that means we can actually express term 50 in terms of A and D. So let me just keep this on the side. This is just info to find this. Okay, so it means that term 50 can be expressed as A plus 49D. Okay, so one number less than the term value, and then A is just the same. So that would mean to find the sum of 50 terms, we would say S of 50 is equal to, and we would say again n over 2, which is 50 over 2. And then A is just A, and then plus the last term, which is term 50. That is A plus 49D. And let's just simplify this. Now we're going to substitute because this is an equation. So in terms of S of 50, we're going to put down the value they gave us, which is 1,275. So 1,275 is equal to, and we have 25, and this is 2A plus 49D. And at this point, you can just divide both hand sides of the equation by 25. And now we have, so I'm just going to find that. And this is 51. So 51 equals, and we have 2A plus 49D. And then at this point, yeah, we just look stuck at this point. Fine. So they did tell us to find the sum of term 25 and term 26. So why don't we do the same thing for this? They're just terms as well. Term 25 can be expressed in terms of A and D, and so can term 26. I'm sorry, I noticed I wrote 25 and 25. It's 26. Okay, so let's also do that. Term 25 would be A plus 24D, and term 26 would be A plus 25D, meaning term 25 plus term 26 is equal to A plus 24D plus A plus 25D. Okay, and this is making sense now. So these two go together and they become 2A, and then that is plus 49D. Where did we see this? We saw this here, okay? That sum of 50 terms equation simplified to. It said that this 2A plus 49D is equal to 51. So if term 25 plus 26 also summed up to 2A plus 49D, what does that mean about them being added together? It means that this is therefore equal to 51. You see how these two are exactly the same? So it means that term 25 plus term 26 is actually equal to 51. And that is our answer. Funny type, but you have to just think it through and then ask yourself, why are they given certain things? Because there were too much things that just looked incomplete. So try to express it in the simplest way possible. And because it was an arithmetic sequence, we could do this in terms of A and D. So in a situation where you have a geometric sequence, you would have to express it in terms of A and R. Okay. So yeah, that is our answer. And that is it for question 2. Question 3 says, for which values of x will the sum of the series with this formula, okay, you can already see the exponent is the variable. So this is geometric, of course, and it's heading to infinity, starting at k equals 1 ending at infinity. So for which values of x will the sum of the series exist? It's heading to infinity. The only way the sum can exist is if this is a converging series. And a brief explanation, here's an example of a converging series. Let's say our ratio is 1 over 2 and the first term is 2. So the next term would be 2 multiplied by half, which is 1. And then the next term will be 1 multiplied by half, which is a half. And the next term is a half multiplied by half, which is 1 over 4. And the next term is plus 1 over 8, and then plus 1 over 16, and then plus 1 over 32. Do you see how small these terms are getting? They're getting so small and getting closer and closer to 0, but they're never actually going to reach 0 because of the nature of numbers. Numbers can get infinitely smaller, and that's what's going on here. This is a converging series. We can actually find the sum despite not being able to find the last term, since it's heading to infinity. It may be heading to infinity, but we know that these terms are getting so small and then each term is getting closer and closer to 0. And so because of that, we are still able to find the sum of the series. Okay, so that's just a brief explanation. So they're really just asking you to find the values of x for which this series converges. Okay, and a series converges if the ratio, the constant ratio, is greater than -1 but less than 1. If it is a proper fraction, okay, the absolute value of it, like that, a half. Okay, so because you keep multiplying it by something that makes each term smaller. Okay, so this is all we're going to do. Find that common ratio. We can easily see it here. It's always whatever has that exponent, okay, that variable exponent. So we're really just taking this 4x minus 1, right? And if you had to substitute to find your first term, would substitute 1. And then you see term 2 would be 4x minus 1 to the power of 2. So we substituted k equals 1 and then k equals 2. So you could have just said this term divided by the previous term. So term 2 divided by term 1. And you see that if you do that, that all you get is they will cancel. And you're just left with, so this one is gone. Okay, one of it is gone. And so you're just left with 4x minus 1. Okay? Okay, so this means that we're saying that 4x minus 1 is greater than -1, but less than 1. And we would need to solve for x here. Now, there's a specific x value. Okay, it depends on what r is. That is not also going to let this series exist. Think about it. We were looking at how the series converges. If your ratio is equal to 0, and we have to cover this because you see, if you're saying that r is greater than -1 but less than 1, 0 is in between there. So we need to cover this. We need to ensure that the ratio is never equal to 0 because then you're not even going to have a geometric series. Neither will it converge, okay? So we need to ensure that 4x minus 1, our ratio, is not equal to 0. And then just ensure that you find out the value of x for which it shouldn't be equal to 0. Okay, transpose, that's going to give you +1, 4x, okay, and +1, and then divide both hand sides by 4. So we're just saying that x is not equal to 1 over 4, and we'll keep that in mind. Now, of course, if r is also equal to values like 1 or -1, it's also not going to work. But we don't have to worry about this because you see that we already said that r needs to be greater than -1 but less than 1. So it's not going to fall into any of those categories. We only had to cover this. Okay, and now we can solve here. So transpose the -1 on both sides. This is really just two inequalities, but it has been expressed as one because of the relationship between the values. So when we take -1 over, it becomes positive. So that's -1 plus 1, which is 0. And then when we take -1 over here, that's +1 plus 1, which is 2. So we're just saying 4x needs to be greater than 0, but less than 2. And then we can just divide by 4 on both sides. This is two inequalities, okay? It's just expressed like this. So therefore, we have x being greater than 0, but less than, that will give us a half. And that is our answer. We need to make sure we tell them, but x should not be equal to 1 over 4. You see the issue with that? 1 over 4 would have been included in this. Okay, it's going from 0 to a half. 0 to a half, 1 over 4 is there. Okay, so that is our answer. And moving on to the next question. Question 3.2 says, the figure below shows a pattern of 5 circles touching externally, whose centers lie on a straight line of length L units. Okay, so this is just what we have. They are touching each other just right outside. And then when we join this straight line, okay, where all their radiuses are, it just forms a straight line with a length of L units. Probably going to be useful later, we'll see. And then they tell us that the radii of these circles form a geometric pattern. Okay, so working with the radii, where the radius of the smallest circle is 3 units. Radius of circle 1, in other words, term 1 is 3 units. So look at the information they've given us. They gave us the radius of circle 1. The first term, circle 1, is 3 units. And that of the fifth, which is the largest circle, is 48 units. So term 5, the fifth circle, has a radius of 48 units. Okay, and the question is, determine the common ratio of the geometric pattern formed by the radii of the circles. Okay, so they've given us the value of term 1, the first circle's radius, and the fifth circle. This could be a simultaneous equation, but it's not really necessary to solve it like that, because you know that term 1, right, in a geometric pattern is always called A. So this is A is equal to 3. And then we can just use the Tn formula to find the value of R using this information. So because we have the fifth term, so Tn equals A multiplied by R to the power of n minus 1. And we'll substitute everything we have here. So term 5's information, and we know the value of A. So this is term 5 equals, what is A? It's 3. And then R raised to the power of, we said term 5. So in place of n, we say 5 minus 1. Now we know term 5 is equal to 48. So this is equal to 3 times R raised to the power of 4. And now we can finally just solve for R. So divide both hand sides by 3 first. So that's going to be 16. R to the power of 4 equals 16. And then fourth root both sides. Okay. But you don't have to consider the negative in this case, because these are lengths. Remember that R is really just the radius. Okay. So all of these are lengths. So R is really equal to 2. Okay. So that's our answer. R is equal to 2. And moving on to the next question. Question 3.2.2 says determine the value of L. Okay, so we know what L represents. Okay, it's this line that is drawn through like this. But I need to point out something. Remember that this circle, we know the radius of it. It's 3. Now a radius is from the center to the circumference. That would mean that this straight line that we have here includes double the radius of each circle, okay? Because it's like from the center to the circumference this way, and from the center to the circumference that way. And it's the same for each and every circle here. So we can find the sum of all the radii. So add that radius plus this radius plus that radius and add them, right? And we know there are 5 circles, so it's just the sum of 5 terms. But then you need to also consider that we're trying to find the length of L, meaning you need to consider this part of the radii as well. So really just adding the sum of the diameters. So it's fine, find the sum of the radii and then just multiply it by 2 so that you can also include that second part, okay? Because they want the full length of this line, which is the diameters of all the circles, the sum of their diameters. So let's find the sum of these 5 circles. So we're trying to find S of 5. Okay, so Sn equals, and the value of R, our ratio is 2. So I'm going to use this formula, A multiplied by R raised to the power of n minus 1 all over R minus 1. Okay, this is where R is greater than 1. And so we have, okay, so S of 5 is equal to, and remember that A is 3, the first radius was 3, so 3, and then we say R, which is 2, raised to the power of 5 minus 1 over, and this is R, so 2 minus 1. Okay, and let's substitute this and find out the sum of the 5 radii. And that is 93. So this is the sum of the radii. You need to remember that it's only the radius of each circle. You need to also include the other part of the radius. So it's the full diameters. So you need to multiply this by 2. So the sum of all these terms, L, what they were asking for, the value of L would be found by saying 93 multiplied by 2. Okay, 90 times 2 is already 180. So this is 186 units. And that is our answer. L equals 186 units. Okay, unless it was like in centimeters or stuff. It's in units. So that is our answer. And moving on to the next question. Question 3.2.3 says, the pattern is extended by 5 more circles to 10 circles. Calculate in terms of pi the total area of the 10 circles of the new pattern. Okay, so we have a new pattern and now it refers to the areas of our circles. So remember that the first circle has a radius of 3 units. So this is what that area is going to look like. Circle 1, or term 1, its area is going to be pi radius squared. So pi multiplied by, the radius was 3, so that's 3 squared. Okay, and so term 2 would be pi times the next circle's radius. So you see that the ratio was 2, and you can actually just use your TN formula to find it, but it was 2, meaning each term is going to get multiplied by 2 to get to the next term. So 3 times 2 is 6, meaning the next radius is 6. So this is 6 squared. And then you could find term 3, but it's not really necessary because this is already enough to find R. We have the value of A, that is term 1, and we just need R. So we would find R by saying term 2 divided by term 1. And so that is pi times 6 squared. I should just write it like this. 6 squared over pi times 3 whole squared. And so pi cancels here. And 6 squared is 36. 36 divided by 3 squared, which is 9. That is 4. Okay, so we have 4 here. So now the radius of these areas, okay, not the radius, the ratio of these areas is equal to 4. And now we can find the sum of the circles, so 10 circles. Okay, so we're trying to find the sum of 10 terms, these terms, the areas. So that is, we'll use Sn equals, and we have again A multiplied by R raised to the power of n minus 1 all over, I don't know why I'm writing it again. We already have this formula, so we can just start substituting. The sum of 10 terms is equal to, and we'll say A, and the A value here is all of this. This is the first term. So we'll just say this is 3 squared times pi, and then multiply by, now our ratio is 4. So 4 raised to the power of n, which is 10, and then minus 1, all over r minus 1, which is 4 minus 1. And let's find out what the sum of these 10 terms give us. And if you use the calculator, it's fine. It will still simplify it in terms of pi first. Okay, and this is the sum of these 10 circles. It is 3,145,725 pi. And that is our answer. Okay, and that is it for question 3. Question 4 says, the lines y equals x plus 1 and y equals negative x plus 3 are the axes of symmetry of the function, and this is g of x. Also notice that they have made this value positive, but we know that it's supposed to be x minus b. So just remember what to do with that. And 4.1 says, show that p equals negative 1 and q equals 2. Okay, so with this and with what they've given you the axes of symmetry. Okay, both of them. that axis of symmetry, the one with a positive gradient, okay, that's why the gradient there is positive. And they gave you the one with a negative gradient. There's something you need to know about the axis of symmetry of a hyperbola. They intersect, but their point of intersection is specifically at the point of intersection of your vertical and horizontal asymptote. Okay, so here is the full picture. Okay, let's say we have this hyperbola. We might as well just work with it, where the value of a is less than 0. If a is less than 0, it means that your graphs lie in the second and the fourth quadrant. Okay, so you see, that's an axis of symmetry. It cuts the graph symmetrically. That's another axis of symmetry. It also cuts the graph symmetrically. That looks exactly like that. Likewise, this part looks exactly like this part. That's what it means to cut it symmetrically or divide it. So ultimately what happens is these two lines, the axis of symmetry that we have, they intersect at that point of intersection of your asymptotes. So that would mean whatever x value they have, and I think it's just best to actually draw a y-axis. Okay, so let's say the y-axis was over here, right? And let's say the x-axis was just here. It doesn't actually look like that. I'm just putting this here as an example. So that would mean the x value that we have here of that point of intersection, that is that x value that belongs to your vertical asymptote. Okay, that x equals p, that is that. And then the y value of that point of intersection is the y value that belongs to that horizontal asymptote, that y equals q. Now, please note that they have said x plus p, so just keep that in mind. Okay, so since we know it's a common point of intersection, we know how to find p and q. It's that point of intersection, meaning equate your graphs. Okay, it's the point where both graphs are equal. So we'll simply say y equals y, and we're saying x plus 1 equals negative x plus 3. Then transpose. This will become a positive x, so x plus x is 2x equals 3, and then transpose the 1 minus 1 is 2. Therefore, if you divide both hand sides by 2, x equals 1. Now, what this means, x equals 1, this is our p value. This p value specifically, this is 1. You know that the original equation of a hyperbola, here where it says x plus p, it's supposed to say x minus p. So when we input this in here, we would say x minus 1. So what does that mean about their p value, the p value they've given us here? It means that this p is negative 1. Okay, because you can only get x minus 1 by saying x plus negative 1. So that is the value of p. And so we can tell them that p is therefore equal to negative 1. And then we still have to find q. So since the x value was 1, to find the corresponding y value, you take this x value and you substitute it into either one of the graphs because they both intersect at this point. So they have the same y value at this point. So we can simply say y is equal to, and we'll say 1. Okay, we're using this x value, but you still need to tell them what their p is. So we'll say 1 plus 1 using this equation. And so y is equal to 2. And so this means that q is equal to 2. And that is our answer. P equals negative 1, while q is equal to 2. And moving on to the next question. Question 4.2 says, calculate the x-intercept of g. Okay, we have the full equation of g now. We can just rewrite it. So g of x is equal to negative 4 over x minus 1 plus 2. And so to find the x-intercept, we simply make y equal to 0. So 0 equals this. And you see, in this case, you don't really have to transpose the 2. This is already negative in the numerator. So let's transpose it. And now it becomes positive 4 over x minus 1. Nothing happens to the denominator. Transposing it, this negative belongs to the full fraction. It was just sitting in the numerator. And then this is equal to 2. And now we can go ahead and cross multiply. So if you make this a fraction, to make it a fraction, you can put it over 1. Then now that it's a fraction, you can cross multiply. So this is 2 multiplied by x, which is 2x. and 2 multiplied by negative 1, which is negative 2, is equal to 4. And we can transpose the negative 2. So 2x equals, we have 4 plus 2, which is 6, and divide both hand sides by 2, and x is equal to 3. And that is the x-intercept. X equals 3. You can leave it like this because they didn't really say calculate the coordinates of the x-intercept. So that is our answer. Moving on to the next question. Question 4.3 says, sketch the graph of G in your answer book, clearly showing the asymptotes and the intercepts with the axes. Okay, so this is a hyperbola. Let's point out the things that we need and just write down the steps we need to take. So step 1, you need to have your asymptotes, okay? If you draw your asymptotes down first, it makes it easier to sketch this graph. So we know our asymptotes, okay, from this whole discussion. We know that x is equal to 1, okay? Clearly shouldn't be this side. X is equal to 1, and then y is equal to 2. So that's the horizontal, that's the vertical. So we know these now. X equals 1 and y equals 2. The second thing you need to put down are your intercepts with the axes. So you need to put down your x-intercept, which we have. It's 3. So as a coordinate, this is 3 and 0. And then your y-intercept. Now I just noticed this is actually something we don't have. So we need to find this. Okay. So we'll take this equation of the graph, and it's a y-intercept. So to find a y-intercept, you simply have to make x equal to 0. Okay, so in place of x, we'll just say g of 0, and then there's x, replace 0. And this would be, you see, that will give us negative 1. Negative 4 divided by negative 1 is positive 4, plus 2 is 6. So g of 0 is equal to 6. And now we know that our y-intercept is simply just 0 as the x value and 6 as the y value. Okay, so we have our intercepts. That's step 2. Then step 3 is you need to know the shape of your graph so that you know where to draw them. Okay, so our graph has a negative a value. If a is less than 0, remember that your graph is going to lie in the second and the fourth quadrant. Okay, so let's get sketching. So with the graph, just draw down a simple Cartesian plane. Make sure to label your x and your y axes. So now that we have that, the second step would be draw the asymptotes, really the first step. Okay, you need to always make sure you have your asymptotes down so you know where to not go beyond. So x equals 1. This is a vertical line. So we're going to draw a vertical line. Make sure that it's dotted at x equals 1. Just show that it passes 1, and this is x equals 1. And then we need our horizontal asymptote at y equals 2. So this is a horizontal line passing 2. And then make sure that it is also dotted. Y equals 2 over there. Then next we're going to put down our intercepts. So that is 3 and 0. Okay, so relative to what we have here. If this is 1, then 3 is way over here. Okay, so this is 3 and 0. You can put it as 3 and 0. And then we have a y-intercept of 0 and 6. So we can just go up and say, okay, this is 0 and 6 that we have over there. Okay, and then once those points are down, just remember that your graph is going to lie in the second and the fourth quadrant. So it's going to look something like this. So you need to make sure that it passes this point, right? So it's moving closer and closer to that asymptote from here. So we're going to move up and move closer and closer, and it just never touches it. And then on this side, we're simply just going from here, and we're moving closer and closer. We cut through that x-axis, and then there we go. So there's our graph, and you can just label it. This is the graph of G. And that is our answer. Moving on to the next question. Question 4.4 says, for which values of x is g of x greater than 0? Okay, so looking at g of x, where is it greater than 0? This refers to the y values of g. Okay, g of x means y. Y equals mx plus c. You could also say g of x equals mx plus c. So where are the y values of this graph greater than 0? Where are they positive? we know that we have positive y values over here on the y-axis and then negative y values over here. So that would mean that the graph where it will have positive y values would be all the places where the graph lies above the x-axis. You see that everything here has positive y values. This point over here, positive y value. That point, a positive y value. Even these ones, those have positive y values. So everything above the x-axis has a positive y value, and you're just going to select those and then tell them the values of x for which these parts of the graph exist. So if you line these down to the x-axis, look at where these are. These are values that are, where do they start from? You can see that because it's all through here. Okay, we can't just start from here. We don't know what number this is here. And this graph is going to keep going and get closer and closer to that asymptote. So it will still have positive y values, meaning you need to start from over here. Okay, so it's not exactly at 1 because we have an asymptote there, but it's values that are less than 1. So immediately less than 1 and then all through like that. The graph will always have y values that are greater than 0. So we got that one part. X is less than 1. And then on this side, we also have a selected piece of graph. So if you line this down to the x-axis, do you see that the point where it starts is immediately after this x value of 3? So it's values that are greater than 3. We can't really say equal to 3 in this case because at 3, you have a y value of 0. And they only said they want y values greater than 0, not equal to 0. Okay, so this will be x is greater than 3. So those are our answers. We can simply tell them x is less than 1 or x is greater than 3. And those are our answers. And that is it for question 4. Question 5.1 says, the sketch below shows the graphs of f of x is equal to, and you can see that this is a parabola in turning point form. Okay, there we can see the turning points, the x and the y values. And g of x is equal to b to the power of x. This is an exponential function because the variable is in the exponent. Okay, x is in the exponent, where b is a constant. D is the turning point of f and a point of intersection of f and g. B is the y-intercept, and A and C the x-intercepts of f. And the first question, 5.1.1, says, determine the length of AC. Okay, so the length of AC. If you want to find the length of AC, you clearly need A and you need C. This is like the question in question 4 as well. So let's find A and C. How do we find these points? Well, they're x-intercepts. So at these points, this is where y is equal to 0. Even though this is in turning point form, we can simply just make y equal to 0. And it's actually easier to find the x-intercept when it is in turning point form. So let's rewrite our equation. Okay, so finding x-intercept, make y equal to 0. And here's why I say it's easier. You can simply just take this, because it is negative, transpose it. So now it's positive. It's x minus 2 all squared is equal to 9. And then we're trying to get to the x. What's stopping us from getting to the x? It's this 2. So we can get rid of that 2 simply by square rooting both hand sides. So square root and square root. But this is an equation, so you need to consider the positive and the negative solution. So x minus 2 is now equal to positive or negative 3. Therefore, we are saying x is either equal to 2 minus 3, which is negative 1, or x is equal to 2 plus 3, which is positive 5. And those are our answers. So that is negative 1. A is clearly the negative 1, and this is the positive 5. So now we know that to find AC, you can just take the highest x value minus the lower x value. And so AC is equal to 5 minus negative 1, which is going to be plus 1. So AC is equal to 6 units. And that is our answer. Moving on to the next question. Question 5.1.2 says, determine the value of B. Okay, so b from the exponential. So you see, to find b, because it's the only variable missing here, we just need a value in place of y and then a value in place of x, and then we'll find b. So that means we need a point. So look at G, the graph of G. Do we have any point on it? Yes, we actually have a point. Is this point D? Even if we can't see it right now, we have it because the parabola is in turning point form. So the parabola in turning point form means it is in the form of a times x minus p all squared plus q, where p and q are the coordinates of your turning point. So it means that p is 2 and q is 9. So there we go, we have 1 point. So substitute the point D, 2 and 9 into the equation of G. And let's go ahead and do that. Okay, so this is going in place of x, and that's y. So G of x is y. This is 9 is equal to b to the power of 2. And to solve, this is squared, okay? So we need to square root both hand sides to solve. Now, this would be positive or negative, but because it's an exponential function, you know that b should be positive, okay, greater than 0. If it's negative, it's not going to be exponential. It's going to end up creating some sort of zigzag pattern that could either decrease like that or like increase. So it'll alternate between positive and negative values because of that being negative. So for example, when it's raised to an even number, so if it was like -3, right? And you raise it to 1, then you get an answer of -3. And when you raise it to 2, you get an answer of +9. And then when you raise it to 3, you get an answer of -27. You see, this is not an exponential function, okay? So make sure that you remember the base of an exponential function is always positive. So b is equal to 3. And that is our answer. Moving on to the next question. Question 5.1.3 says, determine the values of x for which g of x is greater than or equal to 9. Okay, so remember this point D, right? 2 and 9 on this graph. So they want us to find out where g of x is greater than or equal to 9. Well, we know where it's equal to 9. Okay, it's equal to 9 when x is equal to 2. But where is it greater than 9? What you can do is, you know that this is this point, right? And if you line this to the y-axis, this is this y value 9. That's why it is 2 and 9. Okay, and this is the x value 2. So we want to find out where it is greater than 9. Where does g, the graph of g, lie above 9? Okay, or where does it have greater values than 9? It's definitely not below here. Okay, all of these map to values less than 9. It's all the way above here. Okay, so we're going to line that to the x-axis to better understand what this is. If you line it to the x-axis, it's shooting this way. So these are the values that we get. Okay, they are values that are to the right-hand side of 2. So these are values that are greater than 2. And it will keep shooting like that. So it's always going to be values greater than 2. So we can say greater than or equal to 2. Because at 2, we have an actual y value of 9, so equal to 9. Okay, so our answer there is x is simply greater than or equal to 2. And moving on to the next question. The next question says, write down the equation of h if h of x is equal to f of x plus 2 minus 9. So you need to look at the translation going on here. The plus 2 is being applied to the x, meaning in your equation of f, wherever you see x, add a 2. And then we have minus 9. But you see how this is outside the function. So this now represents y, because once you apply that plus 2 to the x, that's going to give you your full equation, your new equation, whatever that is. F of x equals what. Okay, f of x plus 2 specifically. But this represents y. And now what they have done is taken this and said minus 9. So they've taken the y values and subtracted 9 from it. Okay, so we're just going to apply this to this graph of f. So the graph of f, I'll just rewrite that. It looked like this. Okay, so this is what f looked like. So we can write h of x is equal to, and just write the translation. It's f of x plus 2 minus 9. So the rule is wherever you see x, just add a 2 to it. So we're going to go and look at f of x and say this is negative, and there's our x. okay, x, and we're going to add 2 to it. So plus 2, and we still have a minus 2, then all squared. Then we have a plus 9, and then we're going to say minus 9, okay? So now this is equal to, okay, so you just apply that to the outside, not the inside with the x. And so now we have h of x is simply equal to negative, and you see that those two's cancel. So we just have a negative and an x squared, and those two cancel, and this is our equation. Moving on to the next question. Question 5.1.5 says, how can the domain of h be restricted so that the inverse will be a function? And I just had a feeling they were going to, because I was like, why are they trying to make it look like that? Okay, so here's the thing with a parabola, okay? Negative x squared. You can think about what it looks like. It is just a concave down parabola, okay? And it really looks like that mother graph because it's right there at the origin, okay? Negative x squared. The x and y intercept is 0. Okay, so this is our graph, and the thing about this graph is if you find the inverse of the graph, if you switch x and y, right, what this graph is doing is it is shooting down towards the negative part of the y-axis. If you find the inverse, it's just going to do what it's doing here, but it's going to do that on the x-axis. So it's going to also shoot like this, but towards the negative part of the x-axis. So it ends up looking like this. Now, the problem with this is not a function, okay? It's not a function because there's this test that we use, and it's not really because of the test. It's because with a function, right? For a function to be a function, it needs to have one specific y value per x value or x values. So it can have multiple x values, but it must correspond with one single y value. See the problem with this graph? That's not the case. Say, for instance, this point over here, right? If we go here, do you see how this has this y value, okay? And then for this same x value, say this was like -3 and this was 5. Do you see that -3 also has another y value over here? You have multiple y values for one x value. That's not a function. So because it's not a function, and so that's why we use something called the vertical line test. If the graph cuts this vertical line twice or at least more than once, then it's not a function. Okay, now how do you make it a function? The only way to make it a function is to cut this graph. Now we can't just decide to start slicing the graph and say, hey, we have made it a function. It's not a function yet. You have to control the graph by controlling its domain, telling it where not to have x values or where to have x values. And we can do that at the turning point. So you do that to the original function. We're looking at this original function, and we can either decide to keep this part, okay, so there's two ways you can restrict it. We can either decide to keep this part, or we can keep this part. And so you're going to restrict that domain, and here's how we do that. So you look at this part and say, I want to keep this part, so I'm going to tell them the values of x for which this exists. And if you line this up to the x-axis, you're specifically saying at 0, we're going for values that are all greater than 0. So here you could restrict this graph by saying that x should simply be greater than or equal to 0. And there we go, you have restricted this function. And then a second way to do that would be you can decide, no, I don't want to keep this part. I want to keep this purple part. And then you line it up to the x-axis, and you see that the values of x for which this part would exist would be where x is less than or equal to 0. So 0 is that turning point, the x value of the turning point. So you can either say x is greater than or equal to 0, or x is less than or equal to 0. And there we go, you have restricted the function so that its inverse is now a function. So once you restrict the original, that will have an effect on the inverse. Okay, so you can either have this answer or this answer. You just have to put one of it. And then that is our answer. Moving on to the next question. Question 5.1.6 says, show algebraically that g of x plus a half is equal to the square root of 3 g of x. See, when two things are next to each other like this, they're just multiplying. So we just have to show them that this is true. Okay, we know that g of x is equal to, that's our exponential function. We already found b. Okay, so it's 3 to the power of x. So if this is 3 to the power of x, then let's find out what g of x plus 1 over 2 looks like. And then we'll find out what that one looks like and compare. Okay, so what does this mean? Wherever you see x, just add 1 over 2. So we're going to say 3 to the power of x plus 1 over 2. And this is what we have, right? That's what it simplifies to. So now let's find square root of 3 g of x. Okay, they're next to each other. They're just multiplying. So you're just going to take the square root of 3 and multiply it by the equation of g of x. G of x is equal to 3 to the power of x. So that's 3 to the power of x. Great. Okay, this is making sense because we have these two. You see the base is 3. Just rewrite this as a base to the power of a rational exponent. Okay, like from calculus. So 3, and we have the inside exponent being 1, the outside exponent being 2, because this is the square root of 3. So this is 1 over 2 multiplied by 3 to the power of x. And if the bases are the same and you're multiplying, you need to do what to the exponent? You need to add the exponents. So leave the base as 3, and then this is x plus a half. And you see how they are equal? So this means that g of x plus a half is indeed equal to the square root of 3 g of x. And that is our answer. Okay, moving on to the next question. Question 5.2 says, given f of x is equal to ax squared plus bx plus c, okay, and g of x equals mx plus c, and we can see them in the diagram. If given that f of x multiplied by g of x is less than 0 for all values of x when x is greater than -6 but less than -3, or x is greater than 2, determine the value of a in terms of m. Show all workings. Okay, so let's just keep in mind what they're asking us to do. Value of a in terms of m. So solve for a, and then your answer is going to be in terms of m. It's going to include m in it. Okay, this is a very interesting question. It's a very creative question, really. Okay, so the main goal, the main thing that they've told us, we know this is the main goal, but the information they've given us is that f of x multiplied by g of x is less than 0. Okay, let's think about that and let's unpack that. F of x is all the y values of f multiplied by the y values of g, and they give us values less than 0. Let's see how this can be possible. If the y values of f are positive and we multiply by negative y values of g, we will get a value less than 0, a negative value, okay? And then if the y values of f are negative and we multiply by positive y values of g, then we would also get a negative value, a value less than 0. Let's see where this appears in our graphs. So this is our graphs. I also noticed that they have a common y-intercept at C. Okay, where is the graph of f? Where does it have positive y values? Remember, when you're referring to the y values being positive or negative, all you have to think about is this x-axis. Positive y values lie above the x-axis. Okay, all of these parts of the graph, they have positive y values. And the negative y values lie below the x-axis. So let's select where this happens. So we're just going to find it like this. We're looking for places where f lies above the x-axis and at the same time g lies below the x-axis. So I can't really see that with f because this is all the places where f has positive y values all through here. Okay, so no, not there. So let's look for where g has positive y values, where g is above the x-axis. G is above the x-axis here, all through here. But for those same x values, f is below the x-axis. This is what we're looking for. I'm going to use a vertical line to mark this. You can use a ruler. It will be easier to use a ruler to do this. So I'm marking it at this point because at that point, at that x-intercept, this is where the graph of f starts going below the x-axis. So it works out here. See, g is positive while f is negative. Great. Do we have that anywhere else? Here, do you see that they're both positive? They're just both positive all through here until f goes below the x-axis again. So let's see. Here, where f goes below the x-axis, for those same x values, so use a vertical line so that you can see this. Okay, for those same x values, you see that the graph of g has positive y values. Okay, and then it stops here. So I'm also going to just put a vertical line to mark that end. So I know that it stops here. Okay, and then after this, it doesn't work because this is shooting down. This is below the x-axis, and then this one is also shooting down. It will also be below the x-axis. So we see that it works here and it works here and then nowhere else. Okay, so they say that this is true, right, for all x values where x is greater than or equal to -6 but less than -3. That makes sense now. They are actually marking out these places. So that would mean this -6 and this -3 they were referring to, this happens here. This is -6. This is -3. See, it meets this criteria for values that are greater than -6 but less than -3. And then this x is greater than 2. That's this point over here. Okay, there's 2. And then this is where the x values are greater than 2. You see, that's where it meets this criteria again. Okay, all of these values. Okay, so what does that help us to find? Well, it has helped us to find the x-intercept. It has helped us to find the x-intercept of g and f. How can that help us to solve for a in terms of m? Okay, let's see what we have. The graph of f looks like this, and the graph of g is this. They both have a common y-intercept. So let's take this graph of g, right? Because we have a point on it, and it's just an easier type to work with because it's a linear graph. Y equals mx plus c, and then it has 1 point, -6 and 0. So let's substitute that in there because, you know, this is in terms of m. So we have g of x equals mx plus c, and we're going to substitute this point -6 and 0 because that lies on the graph of g. And so this is the y value 0 is equal to, and we don't know what m is. We know the x value is -6, and this is plus c. Okay, so it simplifies to -6m plus c. 0 equals -6m plus c. This is what we have here. How is this helpful to help us to solve for a? A is in f's equation. Okay, let's rewrite f of x. Let's see what we can do with this. We have 2 points at least. So it's ax squared plus bx plus c. And how can we use this graph to find a? Okay, so we have this graph, and do you see that in this graph, I'm just going to look at this based on the way this is. Okay, we have been given 2 x-intercepts. When we're given 2 x-intercepts, if we have another point, we'll see, do we have another point? Actually do. It's not going to be an actual number, but we have a point, and that is c. You see, c here and c here, they stand for the same thing right now because you can see that they have a common y-intercept. Okay, so also just keep that in mind. You could also make c the subject here. So we can just say that this means that c is equal to, and transpose this, and becomes positive 6m. So we'll hold on to that. Now, with this equation, I think it would be best to use it as the turning point form of a parabola. And that looks like this. We would say f of x is equal to, we keep whatever value is here, so this is a, and we'll say x minus x1, the first root, the first x-intercept, times x minus x2. Okay, just based on the way it looks, the fact that we have 2 x-intercepts. And then we can substitute. So f of x is equal to a, and then x minus, and this is -3 and +2. So this is minus -3, which becomes a +3, and then x minus 2. Okay, this is not bad. Here's why. Because a is still there. Yes, x and y are missing, but we can use this as a point. C is a y-intercept. This is 6m, right? So it means that as a coordinate, its x value is 0, and its y value is 6m. We can substitute this into this equation, so it will include m and a. Okay, so now we're going to substitute this point, this y-intercept of c, which is 0 and 6m. Okay, that we got from here. So this is going to be the x value. The y value is 6m, so in place of f of x, I'll say 6m. And we can't do this because it's a common y-intercept. It also lies on f. So it's equal to a, and then the x value is 0. So 0 plus 3 times 0 minus 2. And this is 6m is equal to, that's going to be 3 and then a negative 2. So they become negative 6. So a times negative 6. Okay, so here, they want us to solve for a. So find the value of a in terms of m. So we can just keep a alone. So divide both hand sides by negative 6. And therefore, a is finally equal to, that becomes negative, and that's m. So negative m. And there we go. A is equal to negative m. And we have solved for a in terms of m. And that is it for question 5. Question 6 says, the sketch below shows the graphs of g of x is equal to, we have 2 to the power of x plus q, and f of x is equal to log x to the base of a half. And then we have the graph of f and the asymptote of g intersect at b, which is a half and q. So the graph of f and the asymptote of g, they intersect. So what does that mean? Well, it just means that this line, its y value, is the exact same y value as this point. So if we find out what point B's y value is, then we will know what that asymptote of g is. Okay, so the first question is to write down the coordinates of A, the x-intercept of f. So use it as what they said it is. It's the x-intercept. It's the point where y is equal to 0 on f. So the equation of f is the log graph. So we're just going to say f of x is equal to log of x to the base of a half. And we're going to make y equal to 0. So this is now 0, and you can just rewrite it in exponential form so that you can solve for x. So the base is a half. So we're going to say a half raised to the power of, you always raise it to the power of your subject because log makes the exponent the subject. So we're going to say to the power of 0 is equal to x. And so therefore, anything to the power of 0 is 1. So x is equal to 1. And the coordinates of A, that x-intercept, are 1 and 0. And that is our answer. Moving on to the next question. Question 6.2 says, determine the domain of f. Remember, the domain are all your possible x values. Okay, so all the x values of this graph. So looking at the graph of f, it is the log graph. Okay, this is our log graph. What are all the possible x values? Well, when you were looking at it on the graph, it's very simple to see because you can see that it's moving closer and closer to the asymptote and it's never touching it. So if you line these values down to the x-axis and see where do all the x values of this graph exist, you can see that right after 0, that's where we start having x values. So these are values that are simply greater than 0. Okay, now that is really our answer. X is greater than 0. But I just want to point something out with this. You see, this graph has the log graph. It has a vertical asymptote because if you found its inverse, an exponential function, it would have a horizontal asymptote. Now, how you know that that inverse horizontal asymptote would be on the x-axis like this, okay? So if you had the inverse of this graph, okay, so it goes like that, so it will do this, right? How you know that it is 0 and it's not any other number, this is how you can point it out. Think about an exponential graph that actually has a horizontal asymptote that is not 0. Something like this. Y equals, let's say, 2 to the power of x. That's 3, right? If you had to find the log graph, the inverse of this, you would swap x and y. So x equals 2 to the power of y plus 3. Then you would make y the subject. We need to make y the subject. So let's transpose the 3. X minus 3 equals 2 to the power of y. Then to make y the subject, you use log. So this would be y equals log your base is still 2, the value carrying the exponent, and then the answer that we'll have here is x minus 3. Do you see now that when you have a case like this, it means that this log graph, if you found the inverse of it, it would be an exponential function with a horizontal asymptote that is not 0. Okay, I hope that explanation was helpful. I hope it helps somebody, but I'm just trying to point that out so that you know it's not an assumption we're making, okay, that it has a vertical asymptote. Moving on to the next question. Then 6.3 says, determine the equation of the inverse of f in the form of y is equal to. Okay, so you see the graph of f, this log graph. Let's find the inverse, the exponential graph. So f of x is equal to, we have log, our base was 1 over 2, okay, and it's log of x. So if this is what we have, we're going to swap x and y. So let's just rewrite this as y equals, and then switch x and y. This is now x is equal to log, and the base is 1 over 2, and then we're going to replace x with y. And now just make y the subject. Okay, to make y the subject, think about how you're going to rewrite this in exponential form, because then that will make y the subject. So your base is 1 over 2, 1 over 2. So remember, in this format, it always makes the exponent the subject. So this is raised to the power of x, and this is our answer. So y is equal to, that is the subject of the exponential. And that is our answer. And moving on to the next question. The next question says, sketch the graph of the inverse. And then they say indicate on your graph the intercept or intercepts with the axes and the coordinates of one other point on the graph. It's always best to use a point that is already here. Do we have a point on F? Yes, we do. We have an x-intercept. Okay, so think about it. X and y with inverses, they switch places. If you had an x-intercept in the log graph, what are you going to have in the exponential function? You're going to have a y-intercept. So let's keep that in mind. A, we already found to be 1 and 0. So we know this is 1. And so I'm already going to show you what the graph will look like here. And you can plan it out from here already. So we're going to switch places. I've already drawn this graph technically. But we're going to switch x and y. And so you see what this graph is doing over here. Look at the axes and then what it's doing. It's moving down, but it starts from the negative part of the y-axis and then towards the positive part of the y-axis. That's when it moves closer and closer to the y-axis. So it's going to do this exact thing that it's doing, but using the x-axis. Okay, so on the y-axis, that's what it's doing. Now look at what it does on the x-axis. So on the x-axis, it's also going to start at a high point on the negative part. So here's the negative part of the x-axis. It starts up and then it's going to shoot down as it moves closer and closer towards the positive part of the x-axis and as it moves closer to that x-axis. So that's what it's going to look like. And then you can just draw your graph and then state that instead of an x-intercept, it will have a y-intercept. So this was 1 and 0. It's going to have a y-intercept at 0 and 1. And yeah, we're going to have to find another point as well. So the other point they're probably referring to is B. You see how B is on the graph of F. Okay, it's on that log graph. We know what this is. We know that this is a half. The x value is a half. We just have to find the y value. That's all. So let's find Q. Interesting way to tell us to find Q. So we can go ahead and find that. So let's write the log graph. This is f of x is equal to, we have log and our base is a half, and we're going to, in place of x, substitute 1 over 2, and then in place of y, substitute q. So we're saying q is equal to log, and our base is 1 over 2, and in place of x, we're substituting a half. Okay, now this can be found on your calculator. So just say log and then put that base as 1 over 2. And this is 1 over 2. And there we go. It's 1. So Q is equal to 1. Great. We know this. Okay, so the point on F, right? On F of x, this point, its x value is 1 over 2. Its y value is 1. But then on the inverse of F, right? this is going to switch places. So it won't be 1 over 2 and 1. It's going to be 1 and 1 over 2. Okay, let's just sketch our graph. Okay, so here is our Cartesian plane. It doesn't even need to be this long, honestly, because we already know what the graph looks like. You can plan it out on your question paper, so you know exactly what it looks like. So it's going to go down like that. We're going to have that y-intercept and the one other point. Okay, so let's draw that graph. So from here, we simply just go down like that, and that is our exponential function. And we'll show them that this is the inverse of f. Okay, and we have a y-intercept at 0 and 1. Okay, and then the other point that we have is this point 1 and 1 over 2. So that is 1 and 1 over 2. See, it makes perfect sense. So maybe somewhere here, 1 and 1 over 2. And there we go. That's our graph. And moving on to the next question. Question 6.5 says, determine the equation of the asymptote of g. Okay, you remember when they said that that the graph of f and the asymptote of g intersect at this point b. And all we had to do was find out what that y value was, which we did. We found out that q was 1. Okay, so since q is 1, its y value is simply 1, meaning the equation of this asymptote of g, this horizontal asymptote, it's a horizontal line because it passes one single y value. So it starts as y is equal to, and it's just 1. And there we go. That's the equation of the asymptote of g. We'll just tell them it is y equals 1. And that is our answer. Moving on to the next question. And then question 6.6 says, describe in words the transformation of g to the inverse of f. Okay, we're going from g to the inverse of f. I'm going to just look at this because, you see, that's why drawing a rough sketch of it is helpful. So looking at g, how did we get from this to a graph that looks like this? Well, you see how this one appears here, okay, starts in the y-axis, starts in the first quadrant, but then this one starts in the second quadrant. It's because this was reflected through the y-axis first. So when you reflect it through the y-axis, it ends up looking like this. Okay, it's like a mirror image. It just flips over like that. Okay, so that will get us from here to here. Okay, to this looking like that. But do you remember the graph of g still has a horizontal asymptote of 1, y equals 1. But the graph of this inverse, it doesn't have that. Its asymptote is at y equals 0. So that means for you to have gotten this graph, right, to flip over like that, you did that, and then you shifted it down by 1 unit. Okay, so it looked like this when you reflected it across the y-axis. So it just goes like this and flips over. Then you have to actually pick it up and then move it down so that its horizontal asymptote is also y equals 0. Okay, it's just the way I'm drawing it. Okay, so in a nutshell, just does this. Then you have to flip it over so it's reflected in the y-axis. Okay, like this. And then you have to shift it down so that it does the same thing that the graph of the inverse does. Okay, my inverse just looks too linear. That's the problem. Okay, so that's the story there. It was reflected through the y-axis. Okay, reflected in the y-axis and then shifted 1 unit down. Or we can say translated 1 unit down. So that would be the transformation in words. Okay, and there we go. So that is it for question 6. Question 7.1 says, an investment earns interest at a rate of 7.5% per annum compounded quarterly. Calculate the effective annual interest rate of this investment. Okay, so we are dealing with nominal and effective interest rates. So just a brief background on this. The nominal interest rate is what you are quoted, and then the effective annual interest is the interest rate you actually get when you look at that compounding for the full year. Okay, so the effective interest rate is usually going to be more. And the reason why is because interest builds on interest, okay? And so because of that, at the end of the year, that interest rate is actually more than what they quoted you. Okay, so with that, you can see that they asked us to calculate the effective interest rate, meaning they have given us a nominal. Okay, so here's the formula. It's simply 1 plus I effective. Now, normally you'll see this formula say to the power of 1. It's just because it's per annum, but we don't really need to write that one. So it's equal to, and we'll say 1 plus I nominal. Now, this has a compounding, so it's over n raised to the power of n. Okay, so we're finding the I effective, and what is the nominal we were given? We were told that the investment earns interest at the rate of 7.5% per annum compounded quarterly. You will notice that the nominal will always have a compounding quarterly, monthly, semi-annually, and so on. Okay, so we're going to say 1 plus, and we'll write that interest rate as a decimal, which is 0.075. You can always just say 7.5 over 100 and then convert it into decimal notation. So this is over n, so it's compounded quarterly, meaning we're going to divide this by 4 so that it earns interest every quarter, and then raise to the power of 4. And now all we have to do is make I effective the subject. So this is I effective is equal to, and then 1 plus, we're just going to rewrite everything and then just put this on the calculator. It's first going to give us a decimal. So transpose that 1 and it's negative. And let's find the answer. Okay, so let me write it as a decimal first. So this is equal to 0.0771. Okay, and then it needs to be written as a rate. So multiply it by 100. So if we take that and we multiply that answer by 100, we get the effective interest rate is 7.71%. Okay, and then you see that we had 7.5%, but now it's 7.71%, okay, which is higher. And that is our answer. Moving on to the next question. Question 7.2 says, rhino poaching is a serious problem and has resulted in the black rhino becoming an endangered species. Statistics show that there were 60,000 black rhinos in 1970 and only 4,200 remaining in 2011. Determine the annual rate of population decrease as a percentage over these 42 years. Okay, so they're asking for a rate. If the rate is compound decay. Okay, so they really told you everything here. So we see that we're using compound decay, which the formula looks like this. A equals P times 1 minus I raised to the power of n. Okay, so the starting amount, we started off with 60,000 black rhinos in 1970. So that is the amount we start off with. It was 60,000, and then they went down to 4,200 in 2011. So this is the amount we have ended at in 2011. And then we'll say 1 minus, and the interest is what we're trying to look for. But do you notice that they said determine the annual rate? So this is not compounded monthly or anything like that. The annual rate, okay? We want to see that decrease per year. So we can simply say I and then raise to the power of how many years are we looking at? They even told us the years. They didn't even make us calculate it. They said over these 42 years. So raise to the power of 42. So all we have to do is solve for I. Okay. So how do we find I? We just need to get closer to it. We need to get rid of the 60,000 first. So we can divide both hand sides of this equation by 60,000 and 60,000. And might as well just start dividing now. So cancel out 2 zeros, cancel out 2 zeros. So just say 42 divided by 600 so long. Okay, so 42 is a multiple of 6. So 6 is a common factor. It's actually the highest common factor. So we can just say 42 divided by 6 is 7 over, and then 600 divided by 6 is 100. 7 over 100 is equal to, this cancels, and we have 1 minus I raised to the power of 42. Now we're still trying to get to the I. So we're going to get rid of that power of 42. So we will find the 47 second root of both hand sides. But I'm not going to find that answer. I'll leave it like that because I don't want to work with decimals for now. And so this breaks open. And now we have here, we have 1 minus I is equal to, again, the 42nd root of 7 over 100. And then we can transpose the I since it's negative. So it now becomes positive I. And we're saying this is equal to 1 minus this value. And that's all we have to find. So let's just find this on the calculator. And then, of course, rewrite it as a rate. So that is 0.0613. And then if you multiply this by 100, so equal to multiply by 100. And now we have that rate that they were referring to, we can just tell them that the rate is, and this is 6.14. It's going to round up. 6.14% per annum, per year. And that is our answer. And we move on to the next question. Question 7.3 says, Adam inherits 27,000 Rand, which he invests in a savings account. A savings account, okay? And then they say the interest is calculated at 5.4% for the full period. Then, 3 years later, okay, after he invests the initial amount, he withdraws X Rand to make a down payment on a car. Calculate the value of X if he accumulated 17,614.76 cents in the savings account after 10 years. So from this question, you see that this is not a future value question, okay? Someone is not saving money every month or depositing money into an account every month. There's one amount, 27,000, which he inherits. And then he gets this amount and he invests it, right? Then we know that this savings account, it lasts for 10 years because they told us after 10 years, he has this amount. So at T10, he has 17,614.76 cents. We also know the interest is 0.054 compounded monthly, so over 12. And we are told that after 3 years, okay, so from this, you can see that this is not a future value question because one amount is invested and then, of course, he makes a withdrawal. This is a timeline question. So with timelines, it's easier to start at T0 because you can monitor the interest that is gained, okay, per time period. So I'm looking at these as years. So at T0, this is where he invests the money. Then after a year at T1, it's going to gain interest worth 1 year. So what they tell us is that 3 years after he invests this, then at T3, okay, then he withdraws money. X Rand is taken out of this account. Okay, so here he invests, here he withdraws. And we already know the total amount in the account. So we need to find out how much he actually took out. So here is the story with investments and withdrawals in timelines and really just in accounts. When you invest money, it's not just that amount that is there at the end, it's that amount plus interest. But when you withdraw money, the same applies, okay? You withdraw money, great, yeah, but then the interest that money was supposed to make is also gone. So we're going to have to look at it like that. So with every entry point, here we have 27,000 going in. That's what we're going to look at to start our calculations. So it's still compound interest growth. Money is still being invested. So we're going to use A equals P times, 1 plus I raised to the power of N. Okay, so we can just say A is equal to, and the amount invested first is 27,000. Now you're going to have to look at each of these. So what I mean by entry points are like the money invested, the money taken out. You're going to have to look at this and see the story with it. This amount was invested at this interest rate, but how long did it stay in the account for? Because it came in at T0, it's going to stay for a total of 10 years. So we're going to say 1 plus the interest is 0.054 over 12 raised to the power of, it stays for 10 years. But of course, this is compounded monthly. So we say times 12, okay? So it gains interest every month. Then the next thing that happens is he takes out money. So we'll say minus the amount he takes out, which is X. The interest he takes out also leaves. So we'll say 1 plus 0.054 over 12 raised to the power of. Now, how many years worth of interest is this money losing? It left the account at T3. So that is 7 years worth of interest, 10 minus 3. So that is 7 years multiplied by 12. Okay, so this is what our timeline looks like. And this is the calculation. But we also know that at the end of the period, he ends up with this amount. And that is our accumulated amount. So that is the 17,614.76. Okay. And now all we have to do is look at this and look for the neatest way to simplify it. So first, I see that this is negative. We might as well transpose it to make it positive. So now it is positive x multiplied by, you see, this is repeated. So we might as well just find the value of that fraction. That's simply going to be 1 plus 0.054 over 12. Okay, it gives a nice decimal. If not, I was going to take it as a fraction, but the decimal is fine. So 1.0045, okay? And then raised to the power of that amount, because it says 7 times 12, you might as well just say 7 times 12 is 84. So raised to the power of 84, and then is equal to, and now that this has come to the left-hand side, what are we left with? We're still left with this on the right-hand side. So we'll write this as 27,000, and then this is 1.0045 raised to the power of, that's 120. And then we can just take this over. So we're transposing this, which is 17,614.76. Okay, so at this point, you see that in order to get to x, all you have to do is get rid of this number. And this is being multiplied to the x, so we need to divide by it to get rid of it. So we'll simply divide both hand sides by this number. So x is equal to, and I'll rewrite all of this, and then let's put it on the calculator. Okay, so our answer is finally x is equal to, and it is 19,656.28 cents. And that is our answer. Okay, and that is it for the financial math section of this paper. Question 8.1 says, determine f prime of x from first principles if f of x is equal to 2 minus 3x squared. Okay, so we need to determine the derivative from first principles, meaning we need to find f of x plus h first. So wherever you see x, replace it with x plus h, and we have 2 minus 3 multiplied by x plus h all squared. And this is equal to 2 minus, now we need to distribute that first, so open a bracket, and we square the first term, that gives us x squared, square the last term, gives us positive h squared, and then first term times second term is xh, then we multiply that by 2 to give us 2xh. And now we can go ahead and distribute that negative 3 in. So 2 minus 3x squared minus 6xh minus 3h squared. Okay, and here is our formula to find f prime of x from first principles. So it's equal to the limit as h approaches 0, and we have f of x plus h minus f of x all over h. So this is equal to the limit as h approaches 0, and in place of f of x plus h, we're going to substitute our f of x plus h, and then we're subtracting by f of x. Now you see that f of x has two terms, so it has to subtract by the 2 and the negative 3x squared. So we can protect it with brackets to ensure that it does apply to that. So that's 2 minus 3x squared all over h, and then distribute. So everything's going to stay the same, we're just going to distribute. So this becomes negative 2 and then plus 3x squared. Okay, so all we know is that we were subtracting by this, so this is going to cancel with whatever it is like with. Okay, so 2 minus 2 is 0, and then negative 3x squared plus 3x squared cancel. And now what we're left with is the limit as h approaches 0, and we have negative 6xh minus 3h squared all over h. And now we can solve the problem that we had, which was that the h is in the denominator. So at this point, we can't just evaluate. And so we're going to take that out as a common factor. So h, and then we have negative 6x minus 3h, and we have all over h. And this is equal to the limit as h approaches 0, and then they cancel. Okay, so you can rewrite it one more time, like, okay, this is what I had before substitution, and then finally, f prime of x is equal to, and we have negative 6x, and in place of h, we substitute 0. And so this means that f prime of x is therefore equal to negative 6x, and that is our answer. You can always make sure to double check by using the rules of differentiation to derive this so that you see that you do get to your final answer. Okay, using the rules, f prime of x will simply be equal to, this is a constant, so you derive it, it becomes 0, and then coefficient times exponent is negative 6, exponent minus 1 is 1. And you don't have to rewrite that one. So there we go, and we know our answer is fine. Moving on to the next question. Question 8.2.1 says we need to determine f prime of x if f of x is equal to this, and this is in terms of a. But please note that this is f of x, and we are finding the derivative in respect to x. Okay, so this, despite the fact that it's an a, it's still going to be considered as a constant because it's not in terms of x. Okay, so this means we're saying f prime of x is equal to coefficient times exponent. We have 8x, exponent minus 1 is 3, and then coefficient times exponent is negative 3, and we have x, the exponent on that x is a 1, so exponent minus 1 is 0. Anything to the power of 0 is 1, and negative 3 times 1 is negative 3. This is a constant. If you derive a constant, it simply just becomes 0. And so this is our answer. Okay, moving on to the next question. The next question, we have to derive this. Now, looking at it already, there's a third, there's also a denominator of x. So we need to fix this. So we're not going to write this equal to yet because we are not deriving yet. We need to fix it. So the first thing we can do is split these into separate fractions. So the reason they are together is because you had a 2x to the power of 3 over x and a minus the square root of x over x. Their denominators were the same, so we were able to put them together. Now, this third doesn't have to stay like this. We can change this so that it has a rational exponent. So we're going to rewrite that base. And then the inside exponent is a 1, but this is a square root. So the outside exponent we have there is a 2. So we're going to say inside exponent over outside exponent, meaning 1 over 2. And now we can simplify these fractions. So dx, and we have 2x to the power of 3 divided by x. You see that an x would cancel there, and we have squared left there, okay, x squared. And so this is 2x squared, and then this one, you're really just saying, if we are dividing by the same bases, we're going to subtract the exponents. So the exponent of a half minus this exponent here, which is a 1, which becomes negative a half. So this is minus x to the power of negative a half. Okay, and this is what we have. Now we can go ahead and derive this because this is ready to be derived. So coefficient times exponent is 4, exponent minus 1 is 1, and then negative 1 times negative a half is positive a half. And then exponent minus 1. Negative a half minus 1 is the same thing as saying minus 2 over 2, which is negative 3 over 2. And there we go. You can choose to leave your answer like this with a negative exponent. You can also rewrite it with a positive exponent as well. Okay, but at this point, it's fine. And that is it for that question. Moving on to the next question. Question 8.3 says, the following information is given for a function f. Okay, so we have f of 4 is equal to 5. Now, what that means is that if you're saying f of 4 is equal to 5, it means that the x value 4 on this graph of f has a y value of 5. Meaning, we're just saying there lies a point on the graph of f with the coordinates 4 and 5. And then we have f prime of 4 is equal to 7. What that means is f prime means gradient. So this is the gradient of the graph of f at the point where x is equal to 4. That gradient is equal to 7. So they've given us information about a point and the gradient at that point. The gradient at this point is equal to 7. And the question says, determine the equation of the tangent of f at x equals 4 in the form of y equals mx plus c. This is the information about the tangent. You see, it's at x equals 4. So we have a point and we have the gradient. So we can find the equation of this tangent. So you can use y equals mx plus c, or you can also use this formula. Y minus y1 is equal to the gradient times x minus x1. And so x1 and y1 are your points. So that's x1, that's y1. And we're going to say y minus 5 is equal to our gradient of 7 multiplied by x minus 4. And just distribute. So this is equal to, distribute here, 7x, and then minus 28, and then plus 5. So y is finally equal to 7x, and then that just gives us negative 23. And that is our answer. Okay, and that is it for question 8. Question 9 says the function f of x is equal to 2x cubed plus px squared plus qx plus 3. So immediately you see that there are two missing variables here. And then they tell us that this function is drawn and we have n and m are turning points of f. G is the y-intercept of f, and a, b, and c are the x-intercepts. And the first question is to show that p equals negative 5 and q equals negative 4. So we have two missing variables. When you have two missing variables, you usually need 2 points to find it, or at least 2 pieces of information. So here's the thing. If we look at the graph, you see that the only point we are given is n. But n is not an ordinary point. N is a turning point. So this means that you can use it twice. You can use it in 2 ways. So we're going to use n as a point, okay, as a point on the graph of f. So as the x value is 2 and the y value is negative 9. And we're going to use it as a turning point. Now remember that with a turning point, at that point, this is where the gradient of the function is equal to 0. The gradient is stationary. It's not increasing or decreasing like the way all these other points on the graph are. So that's what we're going to use here. We're going to use that we know that the gradient of this function, the gradient of f prime of x, at the point where x is equal to 2 is 0. And that's how we're going to get this. Okay, so let's go ahead and take our equation, rewrite f of x first. And now that we have it down, let's substitute it as a point. So in place of y, we say negative 9. So that's f of x, negative 9 equals 2 times 2 all cubed plus p times 2 all squared plus q times 2 plus 3. And simplify, and we have negative 9. Well, we can just transpose that. So it becomes negative 12 is equal to, that is 8. 8 times 2 is 16. So we have 16 there. And this becomes 4. So this is 4p. And that is 2q. Okay. Then we'll just transpose that, of course. So when you take it over, it becomes negative 28. So negative 28 is equal to 4p plus 2. And already I can see that we can make q a subject here. So let's transpose the 4p. So it's minus 4p is equal to 2q. Okay, and if we divide both hand sides by 2, q is simply equal to negative 14 minus 2p. Okay, so that is the equation we have there. We have q as a subject. And now we're going to use this information as a turning point. So we say f prime of 2 equals 0. Okay, the gradient of f at the point where x is equal to 2 is 0. So we need to derive this function first. So f prime of x is equal to, we have 6x squared plus coefficient times exponent, that is 2px, and then coefficient times exponent, that is plus q. But of course, with the exponent, we're going to say exponent minus 1, which is 0. Anything to the power of 0 is 1. And so that's why this stays the same. Okay, deriving a constant just makes it 0. And now we're specifically going to find f prime of 2. Now we'll say 2 in place of x plus 2p times 2 plus q. And we know that f prime of 2 is equal to 0 because the gradient is 0 at that point. So that's going to be 4 times 6 is 24. And then we have plus 4p plus q. Great. Q can also be made the subject here. So we can just say q is equal to and transpose all of this. So minus 24 minus 4p. And this is what we have. And let's equate. So we're saying that q is equal to q. So q equals q. Therefore, minus 14 minus 2p is equal to negative 24 minus 4p. Okay, transpose this. It becomes positive 4p, and we still have the negative 2p, which give us 2p is equal to. And then negative 24, when we transpose, that becomes positive 14. So that gives us negative 10. And then divide both hand sides of the equation by 2. Therefore, p equals negative 5. And now we found the value of p as negative 5, like they said it would be. So to find q, all you have to do is just take one of the equations of q. Okay, this one or this one is perfectly fine. And we'll just say q equals negative 14 minus 2. And in place of p, substitute your p value of negative 5. And we get, that gives us positive 10. So that's negative 14 plus 10. 10 minus 14 is negative 4. And there we go. So p equals negative 5, while q equals negative 4, just like they said. Moving on to the next question. Question 9.2 says, determine the coordinates of G, the y-intercept of f. Okay, now we already have the full equation, but do you see that they already gave you the equation in standard form? So we don't have to do any calculation. You see, the value without a variable, without x, that is your y-intercept. Okay, because if you try to find the y-intercept, you have to make x equal to 0. If everything becomes 0, you're only left with 3. So we can clearly see here that G is simply 0 and 3. So G is 0 and 3. And that is our answer. Moving on to the next question. Question 9.3 says, if it is given that C is 3 and 0, calculate the distance between A and B. So find the distance between A and B, the x-intercepts. Okay, and they gave us C, which is another x-intercept. So if this is 3 and 0, okay, so 3 and 0, why did they give us this? So how does that help us find these? Well, these are x-intercepts. And in order to find the x-intercept, you need to make y equal to 0. Once you make y equal to 0, you have to actually factorize this. And so what they're actually giving us is a factor. They're telling us this is one of the solutions you're going to get. They're giving us a factor and a solution. So we don't have to search for it. Okay, so let's just rewrite our equation of f with p and q being negative 5 and negative 4 first. Okay, and to find the x-intercept, we simply make y equal to 0. Now, at this point, we would need to take 3 and then start looking for factors of 3. We'd have to list all the factors of 3 and then see which ones will give us 0 when we substitute them into here. But we don't have to do that anymore since they told us one of the solutions. So we know that x equals 3, when you substitute this into this equation, it will give you 0. And so we don't have to even substitute anything. We can go ahead and continue factorizing. So I'm going to use the long division method. And to do that, we first draw an L backwards. Okay, like the capital letter L. And here we're going to put that number, okay, that one of the roots that we have, which is x equals 3. So that is 3. And now we're going to list out the coefficients. So that is 2. That's the coefficient of x cubed. And minus 5, minus 4, and positive 3. Then we drag down the 2. And then we say 2 multiplied by 3 gives us 6. 6 minus 5 gives us 1. 1 times 3 gives us 3. 3 minus 4 gives us negative 1. Negative 1 times 3 gives us negative 3. And negative 3 plus 3 is 0. it should always end at 0, and that's how you know that your factors are correct. So here are our factors. You see that we already had a solution here, that x is equal to 3. What that means is that one of your factors, when you're factorizing this equation, one of the factors is x minus 3. Okay, and then the other factors we get from here. So we're going to take this, and these are the coefficients of x squared, x, and your constant. So this is 2x squared plus x, and then minus 1. Okay, of course, this is equal to 0. So x minus 3, and factorizing this, we need factors of 2x squared. That's 2x times x, give us 2x squared. Factors of 1, just 1 and 1, but this is negative. And so one of them needs to be negative. Okay, so we need to make it negative, but ensure that the middle term will stay positive. So which should be negative? We need to ensure that we give the negative to not this, because this is going to become 2x. So you don't want it to become negative 2x. So we're going to give the negative to this one, okay, and give this positive. So when we cross multiplied, you see 2x times 1 is 2x, and then x times negative 1 is negative x. 2x minus x equals x, positive x, and that is our middle term. So our factors are 2x minus 1 and x plus 1 is equal to 0. Okay, so this is our equation factorized, and now we can find a and b, and we'll just find the distance. So we know already that x was equal to 3, or here we're going to say 2x minus 1 equals 0, transpose that, negative 1 is positive, divide by 2 is x equals positive 1 over 2. And then here, x equals negative 1. So we already know this belongs to C, so that's for A and B. Let's just see. There's one that is negative and there's one that's positive. So this is the negative 1, and this is the 1 over 2. So what is the distance AB? What is the distance of this line? You're simply just going to say the highest x value minus the lower x value. Because this is a horizontal line, you don't have to use the distance formula for this. So AB is therefore equal to, and we're just going to say a half minus negative 1, which becomes plus 1, and that is just 3 over 2, or 1.5 if you want to write it like that. And that is our answer. AB is simply 1.5 units. Moving on to the next question. The next question, 9.4, says, calculate the x-coordinate of M, a turning point of F. So one of the turning points. To find the turning point, you can take the equation of the function, and we are going to find out where the gradient is equal to 0. Just remember, with your graph, at the turning point, your gradient is equal to 0. So that's what we're going to do. Find f prime of x. And let's just write this as f of x. If this is f of x, then f prime of x is, we're going to say 6x squared, okay, coefficient times exponent. And then same thing over here, negative 10x, and then minus 4. And the turning points occur where the gradient is specifically equal to 0. So we're just going to equate this to 0. So 6x squared minus 10x minus 4 equals 0. Do you see that we have a common factor of 2 all through? So we can simply divide both hand sides of this equation by 2. Therefore, we have 3x squared minus 5x minus 2 equals 0. And we need to factorize this. Okay, so again, I'm going to use the cross method here. Factors of 3x squared, 3 is a prime number, so 3x times x give us 3x squared. And then factors of 2, also a prime number, 2 and 1. But we need to structure it in a way that one of these have to be negative, so they can give us negative 2. But then when we cross multiply their product, okay, the sum of their product will be negative 5. Okay, so you see, like, this is not going to happen because one of it has to be negative. You're going to have a 3x and a 2x, but one must be negative. It's either going to give you a positive x or a negative x. So just swap these. Make this 1 and make that 2. So now we need to ensure that this stays negative. Okay, for it to stay negative, give the negative to the product that is going to become the bigger value. That would be this. So give this the negative, give that the positive. So this becomes negative 6x, and that is positive x, which indeed does give us negative 5x, just like the middle term we have here. So our factors are 3x plus 1 and x minus 2 equals 0. And solve for x. So here, x would be equal to, so equate it to 0, transpose the 1, it's negative, and divide by 3. So this is negative 1 over 3. Or x is equal to positive 2. So we already have one of them. So we just have to see which one exactly is m. This is the positive 2. So m is the other. Okay. And remember that they specifically said calculate the x coordinates of m. Okay. So they just want the x coordinates. So we can therefore tell them x is equal to negative 1 over 3. And that is our answer. Moving on to the next question. Question 9.5 says, determine the x-coordinate of h, the point of inflection of f. Okay, so you see we have a cubic function. How do we find the point of inflection? Remember that the point of inflection is just that point where the graph changes concavity. It changes from being concave down, in this case, to concave up. Okay, from a sad face to a smiley face. So how we find that point is we find the second derivative of this function, right? And we're going to set it equal to 0. So we could start from the first derivative, which we already found. Here's the derivative when we're trying to find the turning point, that x value, and then derive it a second time. So going to find the second derivative, and we're multiplying coefficient times exponent, that is 12x, exponent minus 1 is 1, and then minus 10, and the x falls away, of course, because of the exponent of 0 that we will have. And then we're going to set the second derivative equal to 0. So we can transpose 10 here, so we have 12x is equal to positive 10, and then divide both hand sides of the equation by 12. Therefore, x equals 10 and 12 have 2 in common. So 10 divided by 2 is 5, and we have over 6. So 5 over 6 is our answer. And that is the x value of the point of inflection. Moving on to the next question. And now 9.6 says, for which values of x will f be concave up? So we just found the point of inflection. Remember how I said that? The point of inflection is that point where the graph changes concavity. So it changes from being concave down to concave up. If we know that the point where it changes concavity is at 5 over 6, then it means that where it is concave up, where it has a smiley face, would be all these values here. So if you map these up to the x-axis, do you see that there are values that are greater than 5 over 6. Okay, so that is our answer. We'll simply just tell them x is greater than 5 over 6. Okay, moving on to the next question. Question 9.7 says, for which values of x is f of x multiplied by f prime of x less than 0? So f prime of x stands for the derivative. You can choose to either draw it, but you don't really have to. Here's the thing. F prime of x stands for the gradient of this graph of f. Let's speak about what the gradient can be. You see, if the gradient of a function is positive, then it means that that graph is moving up, okay? It is an increasing function. It's increasing when you read it, moving from the left to the right. If the gradient is negative, then we will have a decreasing function, okay? So it's moving down if you read from the left to the right. So how you can just see this is they're asking you, for which values of x will you have f of x? F of x stands for the y values of f. So where will the y values of f multiply by the gradient of f be negative, less than 0? So let's look at the possibilities. If we want to get negative values here, we can either look for places where f of x is positive, and then we multiply it by f prime of x, which is negative, then you would get a negative value, a value less than 0. We could also look for places where f is negative, okay, f of x is negative, multiply by positive values of f prime of x, and then we would also get a negative value. So we're going to look for these on our graphs. Okay, so here is our graph, and we are looking for this. Remember, f prime of x being positive, or let's start with negative. If f prime of x is negative, all this means is that this is the place where the graph is decreasing, because decreasing functions have negative gradients. Okay, so let's look for the places where first it'll be easier to work with the f prime first. Okay, so where is the graph of f decreasing? If you read from left to right, here it's increasing, and then here it starts to decrease, and then it starts to increase again. Okay, so it decreases all through here, and you can see that the critical points we need to mark would be these turning points. Remember that this one was negative 1 over 3. Okay, this is negative 1 over 3. So this is where it's decreasing. Now, for the same x values, we need to make sure that f is positive. Okay, so the y values of f must be positive. Let's speak about where y values of f are positive. They're y values, so they relate to whether they have positive or negative values. Okay, positive values on the y-axis or over here. So that is everything above the x-axis. Okay, these are all positive y values. If you find these points and you map them to the y-axis, they all have positive y values. So we need to ensure that the graph is decreasing, and at the same time, the graph of f has positive y values. Where will that happen? That would be, and I'm just going to get the section eraser quick, that would be here. Do you see that here the graph is below the x-axis? It has negative y values, so we don't want that. So where it has positive y values and is decreasing would be this little section over here. Okay, for that it meets both criteria. So to answer them, what is this? Well, the x value here is negative 1 over 3, and the x value here, what is that? We can see that that is an x-intercept, and the second x-intercept we had was b, okay, which is that 1 over 2. So this is where x is greater than negative 1 over 3, but less than 1 over 2. Great. So this criteria has been met. We found that. Now looking at this one, again, you can focus on where f prime of x is increasing first, where it has a positive gradient. So where does it have a positive gradient? Where it's moving upwards. So here it's moving up, and here it's also moving up. For the same x values, okay, or at the same time, we need to ensure that the graph of f is negative this time. So where the graph of f is negative or has negative y values, this will be below the x-axis. All the negative y values are here. So we see that we can't take any of these parts. We can't take this because that's above the x-axis. We can't take that. That's also above the x-axis. And we can only take everything below here. Okay, so we can see what we need to take now. It's just all of the parts that have been selected. So you can line that up to the x-axis, and you see which values these are. So this is negative 1 here at a, and so these map to values that are less than negative 1. So here x is less than negative 1, and here what are these values? Well, they start at 2, or really just immediately after this x value of 2, because this is the x value we have here. And then there are all these values. When you map them up to the x-axis, do you see that there are values that are greater than 2, but then they stop, okay? Values that are greater than 2, but less than 3. So that will be our answer this side. So here, x is greater than 2, but less than 3. So do you see from this, we have 3 sets of solutions. This is a solution, this is a solution, and this is a solution. So we're going to have to write all 3 of them. I'll start with this one because it's more on the left, and then this one, and then that one. Okay, so our answers are x is less than negative 1, or x is greater than negative 1 over 3, but less than 1 over 2, or x is greater than 2, but less than 3. And that is our answer, and that is it for question 9. Question 10.1 says, the events S and T are independent. Okay, just remember what it means for events to be independent. This means that, so we're speaking about S and T, that the probability of S and T is equal to the probability of S multiplied by the probability of T. And then they tell us that the probability of S and T, okay, is 1 over 6. Great. So we have that value. And the probability of S is 3 over 4. And 10.1.1 wants us to calculate the probability of T. Okay, so the main goal is to find the probability of T, and this is the information they've given us. You see that in this equation, we can actually make the probability of T the subject, but then of course we would need to find the probability of S. And that's clearly where this comes in. So this information they gave, it's useful for this, the fact that they are independent. And then the probability of not S, this is what this means. This is the complement of S, meaning we're saying the probability of not S is equal to 1 minus the probability of S. Okay, we're just saying everything other than S. That is the probability of not S. So if you have these two circles and they have an intersection because we have probability of S and T, then this is S, this is T. The probability of not S would be everything excluding S. Okay, everything excluding S. That's why we say 1 minus, so the total minus S. And then that's what we're referring to. Okay, so we can see that we can actually use this information to find the probability of T. Okay, let's start off with this because it can help us find the probability of S, and then we can use it to find the probability of T in this equation. So the probability of not S is equal to 1 minus the probability of S. So the probability of not S, that value is 3 over 4. And this is equal to 1 minus the probability of S. And you see now that you can make this the subject. It's currently negative, just transpose it to make it positive. So the probability of S is equal to 1 minus 3 over 4, which is 1 over 4. So 1 over 4. And great, we have this. And then we can use this here. So we can say the probability of S and T is equal to the probability of S multiplied by the probability of T. Now we have this value. It's 1 over 6. So 1 over 6 is equal to the probability of S. We found that to be 1 over 4 multiplied by the probability of T. And now to solve for the probability of T, you see that we just multiply by 1 over 4. So you can divide both sides by 1 over 4 or just multiply both sides by 4, like 4 over 1, okay, by 4. So this means that the probability of T is finally equal to, this will give us 4 over 6, which is 2 over 3. And that is our answer. Moving on to the next question. Question 10.1.2 says, hence calculate the probability of S or T. So think about what that formula looks like. The probability of S or T is equal to the probability of S plus the probability of T minus the probability of S and T. Okay, this is the OR rule or the addition rule. So this is equal to the probability of S or T. We're just finding this. We already have the probability of S. It's 1 over 4. That's 1 over 4 plus 2 over 3 minus that intersection, which we already had as 1 over 6. So minus 1 over 6. And then we just have to find this. Okay, so here, the common denominator is simply just 12. And then what did we multiply to that denominator to get a 4? We multiply by 3. So we're saying 1 times 3 is 3. And then here, what do we multiply? We multiply by a 4. So 2 times 4. And then minus 1 times 2, which is just minus 2. Okay, so that gives us 8 plus 3 is 11 minus 2 is 9. And then 9 over 12, they have a common factor of 3. So that is 3 over 4. And that is our answer. Moving on to the next question. Question 10.2 says, a group of 200 tourists visited the same restaurant on 2 consecutive evenings. Okay, so twice. On both evenings, the tourists could choose beef or chicken for their meals. The manager observed that 35% of the tourists chose beef. Okay, so they chose beef for the first evening. And then 70% of the tourists chose chicken, okay, for the second evening. And 10.2.1 wants us to draw a tree diagram to represent the different choices of main meals on the 2 evenings. Okay, so show on your diagram the probabilities associated with each branch as well as the possible outcomes of the choices. So draw the entire tree diagram. Okay, so here's what's going on. We have these 200 tourists and they go to a restaurant on 2 evenings. And the first evening they go, so the choices are beef and chicken that they can choose from, okay, for their main meal. So when we're looking at this, right, we're going to look at the probability of them choosing beef and the probability of them choosing chicken. And this is the first evening, okay? And they told us that the manager observed that 35% of the tourists chose beef on the first evening. So evening 1, here's the pick, 35% of them chose beef. So this means 35 out of 100 chose beef. And so what does that mean about those that chose chicken? It would mean that 65 out of 100 chose chicken. Okay, and then they say 70% of the tourists chose chicken on the second evening. Okay, so that was just the first evening, and now we'll look at the second evening. So we know 70% of them chose chicken. So we're going to say 70 over 100 chose chicken. And so that means what was the percentage of beef? That would be 30 over 100. Okay, same thing over here. We know that the percentage of chicken was 70 over 100, and then beef would be 30 over 100. Okay, so they also told us to display the outcomes. Okay, so write the probabilities associated with each branch and then also the possible outcomes. So let's look at the possible outcomes. So here's what could happen, okay, on these 2 evenings. On the first evening, we could have that the tourists chose beef, so beef, and then on the second evening, they chose beef. Okay, so we can look at the outcomes. We can actually just start multiplying them, I guess. They said show the probability of the outcomes. So, okay, the possible outcomes. So I might as well just say the total probability of beef and beef would be, and we'll say 35 over 100 multiplied by 30 over 100. And we'll get those values. Then the next one we'll have, the next possibility we can have is that on evening 1, they chose beef, and then on evening 2, they chose chicken. So the probability of beef and chicken is 35 over 100 multiplied by 70 over 100. Then the fourth outcome we can have is that, so you can see we're done with this branch. Okay, we went beef and beef, beef and chicken, and now we're here. So chicken and beef. On the first evening, they could have chosen chicken, and then the second, they chose beef. And so that will be 65 over 100 multiplied by 30 over 100. And then the last outcome we can have is that they chose chicken, and then they chose chicken as well. So chicken on the first evening, chicken on the second evening. So that is 65 over 100 multiplied by 70 over 100. And these are the outcomes. I guess you can put these values here as well, but they're probably going to ask you questions on this too. Okay, so that is our answer. And moving on to the next question. Question 10.2.2 says, calculate the number of tourists who chose the same meal on both evenings. So the same meal, meaning on evening 1, they took one meal, and then on evening 2, they took the same meal. So that would be beef and beef. We can take beef and beef, or chicken and chicken. Okay, so you can see their values. So we can just write this down first. This is first the probability, because they want us to find the number of tourists. So the probability would be, we'll say beef, and then plus chicken and chicken. And then we'll just add those probabilities. So that is 0.105 plus 0.455. 0.105 plus 0.455. And let's see what we get. Okay, so that gives us 0.56. So this is the probability, but then they want the number of tourists. So if this is the probability that tourists will have the same meal on both evenings, then we have to look at, because remember, it's a probability, so it's over the total number of tourists that we have. Okay, so we're just saying 56% of them, okay, would have the same meal on both evenings. So to find out how many tourists are in this category, you need to find out how many tourists there are in total in the survey. So there are 200 tourists. So to find out the total number of tourists in this category, we'll say 0.56 times 200. Okay, what is 56% of 200? And you see that? That is 112 tourists. So that is our answer. And that is it for question 10. Okay, so that is the last question for this paper. And that is it for this paper. I hope you guys enjoyed it, and I will see you guys in the future videos.